So today's lesson is going to be, it's called binomial radical expressions, but that means, what's a binomial? You had to know this on your last exam. Two terms. So now our expressions have radicals in them, but when we were simplifying them, multiplying or dividing them, we could combine them all into one term. That term just might have had multiple factors. But now if they are binomial expressions, they have more than one term, specifically two in this case. So here you see two separate things that contain radicals being added together. Same idea here, okay? So it's about when can we add, subtract, and how does that work compared to the multiplication and division. So with multiplication and division, it was like you can put together whatever you want. Sometimes it simplifies nice, sometimes it doesn't, but it can all end up under the same radical. We mentioned yesterday that that doesn't work the same way for addition and subtraction. So if we just glanced at part A here, can we combine together those terms using addition? So there's two terms in the problem, this plus the second term right there. So can they be combined together? Why or why not? Damien? Okay, so first thing to look for, do the radicals have the same index? Yes, okay? But we get even pickier when we're adding, right? Like, can we multiply 7x times 8x to the third? Yes, even though the x's have different exponents on them, we can multiply those expressions together. Can we add 7x with 8x to the third and combine them into one term? No, even though they both contain x, because they don't contain the same exponent on x, they're not considered like terms. So a similar idea here. Even though they both contain a square root, that's helpful, but they actually have to have the same radicand, the same stuff underneath that radical in both terms. Is that true in this case? Yes. Okay. So that means we can add together the coefficients of the radical, just like if this was an x and this was an x. Those are considered like terms. When you added them together, you would just keep the x with both of them, right? So like 7x plus 10x is just 17x. You don't change the x in any form. You say this one had a 7 in front of it, this one had a 10 in front of it. When I add those coefficients together, it becomes 17. So this is going to stay the square root of 7bc. Then we even had some variables outside the radical. Again, luckily they both had an a. So we have 14a plus 5a, which is 19a. And then if you can simplify that radical, you would. In this case, are there any perfect squares contained within our radical? No. So there's nothing else for us to simplify, and that's it. Okay. All right, so what about part B? Can we simplify it? Why or why not? CJ? Okay, good. So they're both fifth roots, so that seems promising, but do they contain the same contents underneath the radical? No. So sometimes that's a little tricky. Sometimes they can still be simplified because what's under the radical hasn't been simplified yet. But is there anything we can do to simplify either of these radicals further? No. Okay, so at this point, that's completely simplified. That's the best I can do. This is already simplified. I'm just going to write that down. Or put a box around what's already there because that is as simple as it can get. Okay? So do we understand the difference between what we can do with multiplication and division like we did yesterday versus kind of some extra regulations because of the way addition works that we would have to deal with? Okay? So we have to look a little closer in this case. All right, so I'm going to let you guys work on this for a couple minutes, see what you guys think. So this tile design is made of congruent right triangles. So you can see the right triangles highlighted for you. They have a base of 1, there's the right angle, and a height of 2. And it says, find the perimeter of the tile to the nearest tenth of a foot. So in this case, can you use a calculator? Yes, because it says to the nearest tenth of a foot. So if radicals do show up in my expression, I can put my answer into decimal, which means calculator is okay. So let's do this for us. Make sure you can write it with a radical and then take out your calculator and get it as something with a decimal. Does that make sense? Because our emphasis is on working with radicals. So I want you guys to write the radical expression for the perimeter. And then you can use your calculator to change that into a decimal expression. Okay? So take a couple minutes in your... All right. So I saw a lot of people trying a lot of different things. So I think Quentin kind of said it to me in the simplest way. So Quentin, tell them what you told me. He said, just find the hypotenuse and times it by 4. Okay? So all you need is this length, which is the hypotenuse of the triangle. Perimeter would be 4 of those because the square is made up of 4 of the same lengths along the outside. And that's it. So then the question is how to find this hypotenuse. And I saw some interesting things. I saw some things that looked like 30, 60, 90 action stuff going on. I saw some like people using trig. But how could you figure this out pretty quickly? Maybe an Algebra 1 student actually learns the theorem that can figure this out for you. Just like, yeah, a squared plus b squared equals c squared. So what do we get for the hypotenuse here? Rad 5. Okay. Which means the perimeter of this square would be 4 rad 5. And then did anybody figure that out as a decimal to the nearest tenth? So we'll just say 8.9 because it said, and then we'll say feet because it said it was in feet, right? Yes. Okay? So you guys have worked with radicals before. They came up a lot in geometry when you were dealing with all the different trig as well as the Pythagorean theorem. So it's kind of where our experience in simplifying them comes from. All right, so we talked about only being able to combine radicals that are like terms, meaning they have the same index and they have the same radicand, the same stuff contained underneath the radical. So at first glance, does it look like we can do anything with this problem? No. Is it possible that any of those radicals could be simplified? Yes. So what you need to do is you need to simplify and look again. You need to break them down, rewrite them in their simplified form, and then see if any of them are like terms. So go ahead and take a minute with your groups. Simplify this. All right, so everything ended up simplifying to have a square root of 7 in it, and because they had a like term, we could simplify further. That's right. Well, order of operations technically says do addition and subtraction from left to right, which would be 2 rad 7 minus 5 rad 7 is negative 3. But addition also contains the commutative property, which then means it didn't matter if you added that first. So if you did add first, like the 2 rad 7 and the 3 rad 7, is that what you're talking about, like these?
Well, I thought you would add the 5 and 3.
So still, if you add these together, what do you get? It's a negative 5 rad 7 and a 3 rad 7. So you would get a negative 2 rad 7, and when that adds with the positive 2 rad 7, it would still get 0. So no matter which order you add these terms in, as long as you treat this like a positive 2 rad 7, a negative 5 rad 7, and a positive 3 rad 7, we should still get 0. Okay? Yes? Well, you're getting this. But then what operation is technically between the 0 and the rad 7? Multiplication, and 0 times anything is 0. So in that case, it's like writing 0x. You don't have to write it, right? Because it becomes 0. What if they didn't all have a rad 7, but 2 of them did? What's that? You would combine the ones that could, and is it okay then to get an answer that is a binomial? Yeah, that has 2 terms. That's the best you could do. That would be fine, okay? All right. So now we're going to multiply together binomials. So the difference between this and yesterday is that yesterday we only multiplied together radicals that like everything was under the radical of one and everything was under the radical of another. In this case, the terms have 2 parts, the rational and the irrational part. They have the 1, which is rational, and then the 2 rad 7, which is irrational. So you have a binomial with 2 terms times another binomial. So this is going to work a lot like when you've multiplied together 2 binomials in any other instance, whether it was with imaginary numbers, factors of a quadratic, okay? Same process, just don't mess up your arithmetic. So how am I going to multiply this together? distribution. And some of you think of that as FOIL, which gives you the order when it's binomials. So 1 is going to multiply 4 and give me 4. And then 1 times negative 3 rad 7. 2 rad 7 times 4. And then 2 rad 7 times negative 3 rad 7. It's going to give me this for those of you that like seeing all of those steps, okay? But rad 49 is going to end up being 7. So that's really negative 6 times 7, which is 42. Okay? Right here, these two are like terms, so they can combine together. So negative 3 rad 7 plus positive 8 rad 7 will give me a positive 5 rad 7. And I have 4. And then these two can combine together. Positive 4 plus negative 42 would give me negative 38. And then that would be as simple as I could make that. Okay? Any questions on the multiplication? It's typical as to what you've done before. You just have to remember that that same idea exists with binomials of radicals. Don't try combining things together beforehand that you can't. Just follow the rules that you know exist and that you've used before. Okay? And go ahead and multiply together the two binomials in part B. What do we call those two binomials? Not opposites. It is a difference of squares. Good job. And then there's also another term that we used when we had like a term and the second term was the same but it had a different sign between it. Good, the conjugate, okay? So this would be specifically when we multiply it out, we should get a difference of perfect squares. Kind of in a sense, they might not appear perfect because we had radicals here. And we are multiplying together two conjugates, okay? Go ahead and multiply that out just like you had. Okay, so are we okay with the fact that we got 7? Okay, so somebody tell me what's the amazing things about conjugates. So we're seeing them now here with radicals. We saw them when we had complex numbers. What is so great about multiplying together conjugates in these contexts? That's right. Okay, yeah, you get all whole numbers. Basically, you get rid of what you didn't want. With imaginary numbers or complex numbers that have that imaginary part, when you multiply them by the conjugate, the two terms with I canceled out. You got I squared at the end, which turned into a real number of negative 1, and you got a real number answer. Here, you had binomials that had an irrational part. When you multiplied by the conjugate, okay, where the irrational part was just the second term in the binomial, the thing that wasn't a perfect square became a perfect square inside the radical, so that's simplified. And the terms where you would have had a square root left canceled out, again giving you a whole number. So conjugate is where you have a binomial, so first term and second term, same exact first term, different sign in front of the second term. And basically it creates that situation, like Anna said, is like difference of squares, so that you always get these terms to cancel out, and you get the last term and the first term to square. So what that does is that helps us get rid of radicals, that helps us get rid of any complex numbers, because when those things square, then we get perfect squares, or we get I squared, which all become real rational numbers. Now, if this was a cube root, would that work out as nicely? No. Okay? Because a perfect square inside a cube root, like we talked about yesterday, isn't going to solve all of our issues in that context. Okay? All right, so again, why we like the conjugate so much is to help us when things look like this. So to rationalize the denominator. So this is basically almost like review. We did all of this stuff with complex numbers, and now we're just looking at it with radicals, and you've probably done this with radicals before Algebra 2. Okay? So again, we're going to look at rationalizing the denominator to write what we consider the more simplified version of the expression. But remember, we talked about really being able to shift our minds where someone might not say simplify all the time. They might say mark all the things that are the same, and you're going to have to think how someone could have changed those to make them look different, okay, even though our emphasis right now is on simplifying. So it's not that anything can be reduced in Part A. It's that to be simplified, we don't necessarily want a denominator that is irrational. So how am I going to rationalize the denominator? So if I multiply rad 3 through, it'll help with the rad 3, because rad 3 times rad 3 would be 3. But then it's also going to get distributed to the 6, and then that term will be 6 rad 3, and the radical will still exist. Anna? What do you mean by the opposite? Good, the conjugate. The only reason I correct you is because what would the opposite of 6 plus rad 3 be? Negative 6 minus rad 3. Like you've taken a negative and distributed it through. So I know it's like picky. I know what you meant, but just to get our terminology correct, you know. So we're going to multiply by the conjugate. Again, we have to do the same thing in top and bottom, so it's like we're multiplying by 1 and not really changing our answer. In the numerator, we're going to get 66 minus 11 rad 3. And in the denominator, we should get what we expect. These will end up being perfect squares, and since it's square roots, that should all simplify. And the terms that have the radical should cancel out in the middle. So we're going to get 36 minus 6 rad 3 plus 6 rad 3 minus rad 9. Okay, so these cancel. Rad 9 is really the same thing as 3. So in the denominator, I have 36 minus 3, which will be 33. In the numerator, I have 66 minus 11 rad 3. Can I simplify this further? Okay, what is a common factor of all terms in the numerator and the denominator? 11. Okay, so really I'm looking at this as if I factored out 11, okay, I would be left with 6 minus rad 3 here. And in the denominator, if I factored out 11, I would be left with this. The 11s would cancel. This is my solution. Now, I know that 3 goes into 6. If I choose to go that route to simplify, so here's an equivalent form, something someone else could write that's still correct, but looks different than what you wrote, right, if you wrote this. 6 divided by 3 is 2. That's fine to do. But then what's the second term of your binomial answer? Good. Remembering that that denominator goes with both of those terms. So if you see that and you want to simplify that, that's great. So if you saw this and said, no, I know this goes in there 2 times, it's 2. That's fine and dandy, but you guys have a habit of saying that's 2, and now the 33 no longer exists as a denominator for the second term, but it does. So if you simplify that thing completely, simplify the other fraction as best as you can. Okay? These are the same thing. Okay? The answer could be written either way. Right? Any questions about that? Yeah? All right, we don't really have to worry about part C, but let's do part B so that you guys can get practice and we'll let you start your homework. All right. So we'll simplify our answer in a minute. Sorry, this number underneath here is a 21. Okay. So I chose to multiply by rad 3 plus rad 5. Is everybody okay with that decision? I'm choosing the conjugate because of the difference of squares, things, and everything will get squared. Middle terms will cancel out. That will help me get rid of radicals. Okay? Radicals with index of 2. So I go ahead and do the multiplication. So I get a rad 9 plus rad 15 minus rad 15 and minus rad 25 in the denominator. Exactly how I expected it to work. A radical that will simplify here, a radical that will simplify at the end. The 2 middle terms canceling each other out. Okay? Multiply the same thing in the numerator. In the numerator, I have no expectation. It's going to work out however the numbers are. Okay? So 2 rad 7 times rad 3 would create 2 rad 21. 2 rad 7 times rad 5 would be 2 rad 35. So I simplified the denominator and got negative 2. In the numerator, I still have 2 rad 21 plus 2 rad 35. In my numerator, can I combine either of the terms? No. So they're not like terms. 21 breaks down to 3 times 7, but nothing with a perfect square. 35 breaks down to 5 times 7, but nothing with a perfect square. So the numerator is what it is. It's 2 terms, okay, with different irrational parts of them because of the radicals. Yes. Yeah. So since the radicals don't simplify, I can't combine anything in the numerator. But looking at the denominator, okay, I can divide this into each of these, which would make this look like negative rad 21 minus rad 35. Okay? Everything divided by that factor of negative 2. And yes, negative 2 was the denominator for each of these. So both the sign and the 2 affect each of these terms to create these new terms here. Okay? So this would be another way to write that answer. This would be considered a more simplified version of that answer. Okay? Any questions about that? Yes?
On test,
You'd miss like the 1 point off of the problem. I want your answers right now in simplified form. If I want you to write things in several different forms, I'll ask you a question like I mentioned yesterday, like which of these are equivalent, and then you could decide which ones are equivalent, and then some of them would be simplified and some of them wouldn't, because if they were all simplified, they would look exactly the same. There wouldn't be a question about which ones are equivalent. But when you're leaving an answer, best practice, unless otherwise noted, or you're doing something further with your answer later that you know it's useful to not simplify it, is to write it in the most simplified terms. Okay? All right.